Welcome back to Number Math, in which we apply color to identify and sequence within math. My Math 2 crew, this is your Unit 3B review. Kicking it off with number 1. If we're given the expression the square root of 49, well, the square root of 49 is equal to, yes, it is 7. However, note to self, negative 7 times negative 7 also gives us that positive 49. So our answer is plus minus 7. If it's looking for the solution set, like we will later in number 4, we would just write it as 7 comma negative 7. All right, moving forward to number 2, the square root of 48 is the expression given here. Oh my goodness, you're right. It's not a perfect square. What shall we do? We have to go to the factors, and within those factors of 48, we have to find the largest perfect square. And let's start with 2 times 24. Oh my goodness, neither of which are a perfect square. Get rid of it. And then we will move forward to 3 times 16. Yes, great job. Good call out. 16 is a perfect square. And let me write this out just to show you that the square root of 48 is equal to the square root of 3 times 16. And yes, the largest perfect square is 16. So then when we write our answer, all right, the square root of 3 times 16 is equal to, yes, let's take the square root of 16. That will be our coefficient, which is 4. The 3 that's underneath the radical, go ahead and keep it underneath the radical and circle your answer. All right, and moving forward over to number 3, we have the expression the square root of negative 72. Oh my goodness, 72 is not a perfect square. It's also negative. What do we need to do? Yes, we need to start by finding those factors, because within those factors, we will find the greatest perfect square. Sometimes there is not, but let's take a peek through. All right, starting with 2 times 36. Yes. Go ahead, and what do you like to do? Yes, I do like to put that square around it, because now I know I've found the greatest perfect square within those factors. So the square root of negative 72 is equal to, let's bring up that radical, 2 times 36 times negative 1, because it's negative 72. So we need to add that in there. No, negative 1 may not be a perfect square, but we can take the root of negative 1, and I do square it only because we can take the root of it, which is the I, yes. And we will also put a square around that 36, because we know the square root of 36 is 6. And what's left underneath that radical is that 2, that deuce ball. Go ahead and throw it underneath your radical and circle your answer. Moving forward to number 4, it asks us to find the solution set to x squared equals 36. And to get this x by itself, yes, we need to take the root of it. So we will put the radical there, and what we do to one side, we must do to the other. Now keep in mind, it's looking for the solution set. So x equals, yes, 6 comma negative 6. Go ahead and circle your answer. Moving forward to number 5, it says solve for 3x squared minus 147 equals 0. Well, let's take a look at it. First step we can do is get 3x squared by itself by adding 147, not just to one side, but to, yes, both sides. Great job, wonderful work. All right, bring your 3x squared down, and those bad boys will cancel out, equals your 147. And what can we do to get x squared by itself when we are left with 3x squared equals 147? Wonderful job. We will divide each side by 3, giving us that x squared equals, and 147 divided by 3. Wonderful job, boys and girls, is 49. And again, just like number 4 now, we can find that solution set by, yes, taking the square root of both. Okay, so x squared will give us that x by itself equals 7 comma negative 7. Go ahead and circle your answer. Moving forward to number 6. Oh my goodness, find the solutions. X plus 8 and the quantity squared equals 144. What can we do? Wonderful work, guys. We've been on fire absolutely all week. Please go ahead and put the radical above there to pull that quantity out. And what we do to one side, we do to the other. So when we take the square root of the quantity x plus 8 squared, yes, that simply just gives us our x plus 8. Make sure to bring down your equals. And the square root of 144 is, yes, 12. let's put a comma and let's put that negative 12 in there. I space it out simply just for a small reason because we need to get x by itself. It's hanging out with plus 8. What shall we do? Yes, subtract 8. And what we do to one side, we do to the other side. Wonderful work. Your x comes down. 8 minus 8, get rid of it, equals 12 minus 8 is 4. Bring down that comma. Negative 12 minus 8 is negative 20. Go ahead and circle your answer. All right, moving forward to number 7. It is asking x squared minus 4x minus 21 equals 0. We want the solutions for all of these. It's requesting that we use quadratic formula. However, we do not need to use quadratic formula for all of them. All right, quadratic formula, take a look at it as like using a hand screwdriver, okay? We have to twist it one by one or step by step. Now, if it's factorable, which 7, 8, and 9 are, as well as 19 and 20, we can basically use a power drill and zip right through it. All right, I'll show you the zip right through, and then I will also go through using the screwdriver. All right, we have x squared minus 4x minus 21 equals 0. Let's start by labeling. We have our a value, which is that imaginary 1 in front of the x squared. We have our b value, which is negative 4, and our c value, which is negative 21. If you guys remember from using the diamond method, a times c would be 1 times negative 21, giving us that negative 21. Our b value is simply that negative 4. We drop that right here. And on the other part of the diamond, okay, not the vertical, but the horizontal, we will write our factors that when multiplied get us to negative 21, and when combined get us to negative 4. All right, so we have a negative 7 and a 3. Now, however, if you are not great at finding these factors, there's no problem with using the screwdriver, okay? Just can't use the power drill. All right, and here we go. And let me show you why. Because once you can find those factors, well, we can write it as x minus 7 and x plus 3. All right, let's close that off. Now, if we remember that when in factored form, we can find our x-intercepts, which are the solutions, by just taking the opposite of what's inside. All right, so instead of a negative 7, that would then be a plus 7, or we can just simply set x equal to 7, and we can also set x equal to negative 3. All right, go ahead and circle your answer. That's it, it's done, it's over. But if you're uncertain, yes, we can take the long way home, and we will use that quadratic formula, all right? Now, our formula is just telling us that x equals, and it's asking us for the, we'll put our negative, it's asking us for our b value, which is negative 4. We will add our plus minus to it. All right, we will open our radical. And then it's asking us for our b value again. And every time we are substituting for our a, b, or c, make sure to wrap it in parentheses so your calculator knows exactly what it's asking of you. All right, we'll square it. Minus 4 times 1 times c. Oh, no, that's negative 21. Thank you. Over 2 times a, which is 1. And I will just highlight computation as we go through this, okay? So right here, if we were to enter that into our calculator as a negative, open a parenthesis, put in the negative 4 and close it, yes, it just spits out that positive 4. All right, so x equals, and then we're just going to write this after the computation. Our plus minus right here, just continue to bring it down. All right, now, due to the fact that we already went through this, we know it's factorable. And if you know it's factorable, well, you can do another shortcut when you're doing this, all right? You can simply take everything that's highlighted, and that includes opening up your radical here, all right, and hitting second, x squared, all right, put in your, open a parenthesis, negative 4, close it, hit x squared to square it, minus 4, yes, that means minus right there, 4, minus 4, open the parenthesis, put in the 1, close it, open a parenthesis, negative 21, close it, hit enter. Oh my goodness, we get 10. Why do we get 10 there? All right, because it is a perfect square, meaning that if we did in our calculator negative 4 squared, and let me show this to you so you have that rationale behind it as you move forward. in your calculator. Open the parentheses, negative 4x squared. That will give you a positive 16. Set it and forget it, easy bake oven. Now we will break this down into two computations, all right? Negative 4 times 1, well, negative 4 times 1, all right? We'll also do times negative 21, gives us, let me get rid of the plus, 84. 16 plus 84 gives us 100, and the square root of 100 is 10. All right, so that's why you can also do it for this one. So that eliminates like one of the steps. And then 2 times 1 is simply exactly 2. Thank you, great job. All right, now we write this as two separate equations here. All right, because of this plus minus, we have to do 4 plus 10 and 4 minus 10. So we'll do x equals 4, let me do my plus, 10. All right, we'll set that over our 2 in brown. We will also do x equals 4 minus 10. Set that over our 2 in brown. And we will just work through these. So this first one equals, well, if we do 4 plus 10, and let me just color code this for us as well for all computation. 4 plus 10 is 14. Set that over our 2, and I'll color code one last time because 14 divided by 2 equals 7. Go ahead and circle thy answer. Sorry about that, miscolor. And then if we did 4 minus 10, and again, let me do this here. 4 minus 10, I'll highlight that. That'll be our computation that we conduct is negative 6. We will set that over our brown 2. We will set that equal to, and we will do computation in pink one last time, as negative 6 divided by 2 equals negative 3. Go ahead and circle your answer, and if you take a look, well, we have x equals 7, x equals negative 3, x equals 7, x equals negative 3. We do get the same answer. So as you can tell, if you're great with the factors and you eliminate even the diamond part here, well, you're just writing it once and then simply getting your answers by the flip. Now, number 8 would require one more step, but it's just as quick. Let's go through it. I always like to start by labeling our A, B, and C. Our A is 3, our B is negative 28, and our C is negative 20. All right, I again built in the diamond just to show you. However, when we're comfortable with factors and we can just see them and piece them together, we don't need the diamond, but I will put it in there for you. All right, A times C gives us a negative 60. All right, our B value is negative 28. All right, now the factors that when multiplied get us to negative 60 and when combined get us to negative 28 would be negative 30 and 2. All right, so if you're taking the shortcut, you can really just write it as x minus 30. Let me close that off. And then x plus 2. All right, now remember that when we get those x-intercepts, we're simply just taking the flip of our, yes, negative 30. So that would make it x equals a positive 30. And then x equals a negative 2. Now, because our a value is greater than 1, meaning our a value here is 3, there is one last step we would have to do in order to get this. All right, and we will just divide each by 3. All right, so x equals, and if you put that in your calculator, 30 divided by 3 is 10, and x equals, and we will just write it as negative 2/3. And that is simply your answer. Now we will go through the long way home. All right, which is no big deal. All right, let's go ahead and rock through it. All right, so it wants us to do the x equals. We will put the negative. And again, we're just following the formula up here. But every time we sub in for A, B, and C, we're just going to wrap it in parentheses. All right, so let's follow the formula here. It's asking us to put the negative 28 there. We will close that. All right, we will put our plus minus. We will open our radical. And again, it wants that b in parentheses, which is negative 28 squared, minus 4 times our a value of 3 times our c value of negative 20. Go ahead and close it. And then we set that over 2 times a, 2 times 3. Now again, we will simply work through the computation. All right. If we put this into our calculator, that negative symbol, open a parenthesis, put a negative 28 and close that parenthesis, yes, you get a positive 28 because just like before, that negative b is just the opposite of our b value. The negative 28 simply just becomes, yes, 28. All right, so we will go ahead and write that one down. And again, your plus minus, just continue to bring it on down. That's all. Now, I will go ahead and I will highlight the entirety of this in green. All right. There will be instances when we cannot do that, and I will show you later. However, let's go through it now. All right. If we put this into our calculator, let's go ahead and clear that off. Hit second, hit x squared. That'll give you your radical. Open your parenthesis, negative 28. Close it. X squared minus 4. And again, open your parenthesis, which is times a and times c. So times 3 and times negative 20. Close it. Go ahead and hit enter. We do get an even number of 32. As you can notice, no decimal. All right, that means we had, when we combine those together, we had 32 squared, which equals 1,024. So 32 is in green. And that's why we can do that all as one lump sum there. And let me go ahead and put this bad boy here in brown of 2 times 3, which is, yes, great job, it is 6. And again, we can write this as two separate equations. All right, x equals 28 plus 32 over 6. And then we can also write it as x equals, and let me just go ahead and put that right there. Switch some colors around. 28 minus 32 over 6. And then we will do the computation for both of these. All right, 28 plus 32 in your calculator gives you a 60-piece nugget. We'll set that over our 6-piece nugget. And if we did the computation there in pink, I'll highlight that. If it lets me, there it goes. All right, 60 divided by 6 equals 10. So x equals 10. And then in our calculator, and again, let's solve for the next one. 28 minus 32 in your calculator will give you a negative 4. We will set that over our 6 in brown. And again, we'll do the computation. Let's do that. All right. Ooh, negative 4 divided by 6. If we put that in a calculator, yes, it gives us 0.666667. All right, we need to find the greatest common factor between the two, which is 2. So negative 4 divided by 2. And here's what we'll do to show that. Equals negative 2. And 6 divided by 2 equals 3. And x equals 10. X equals negative 2/3. All right, and as you can tell from over here, well, we found the same answer, and we didn't have to go through an entire process of plugging and chugging. All right, because remember, if you can find those factors, you just write it right here, and then we can simply divide by the a value, which the other 1 and 7 was 1, so anything divided by 1 stays the same. So 30 divided by 3, and x equals negative 2 divided by 3, which gave us our two solutions, or what our x-intercepts are. All right, moving forward to number 9. I will do the shortcut this time, and I'm not going to put the diamond. I'm going to set it and forget it, because I know that negative 8 times negative 5 is positive 40, but when combined gives us negative 13. So right away, I don't need to use the diamond, and this is what I mean. I don't want you to use the diamond either. All right, but if you're not great at finding these factors right away, then don't even use this route. Take the long way home. All right, no big deal. And then we have our solutions, which would simply then be, well, we know it's the opposite, so it would be x plus 8, or, that's right, x equals 8. And the opposite of a negative 5 is a positive 5, so x equals 8, x equals 5. I'll circle that answer, I'll set it and forget it, and I'll begin with the long way home. All right, we have our A, we have our B, and we have our C. And let's go ahead and plug and chug our quadratic formula away. All right, we have our negative. Open up, put in our B, which is negative 13. All right, we will open our radical. Then it asks us to do our b value, and to square it, -4 times our a of 1 times our c of 40, and we will set that over 2 times 1. All right, now let's go ahead and continue on. For the computation in your calculator, everything that I highlight, I want you to put into your calculator if you're uncertain, okay? That gives us a 13, and again, same thing. We can actually break this down into one giant lump because it does come out to a whole number. Now remember, guys, just the way I taught it in class, okay? We can either find that discriminant, and if we take the square root of that discriminant gives us a decimal, well, guess what? It's the same thing as doing this. Then we have to kind of just break it down and further and simplify, which we'll see just a little bit later, okay? Wonderful. We will bring down our plus minus here. And then in green, let's go ahead and let's plug this into our calculator. So we'll start off by hitting second. Hit your x squared. That gives you a radical. Open, -13. Close it. Square it. -4. Open. 1. Close it. Open. 40. Close it. Enter. We get a 3. All right. We will set that over. Yes. 2 times 1, which is simply 2. And again, we will write this as two separate equations here. So we will do x equals 13. Let me get rid of that, put it back. Plus 3 over our brown 2, followed by our equal sign. And then we will simply set it up one more time as x equals 13 minus 3. Set that over our 2 and bring down our equals. And then again, I will highlight for computation purposes. 13 plus 3 gives us a 16. Set that over your 2. 16 divided by 2 equals, yes, and I will highlight just to show the computation of what we're doing. That gives us our 8. Circle that one. And then if we do it one more time, I will highlight our computation. 13 minus 3, yes, is, good job, 10. Let me switch pens and colors. We will set that over again, that brown 2. And then if we do 10 divided by 2, and just to show you that, I will highlight equals 5. And again, as you can see, well, we had to do all of this work just to get 8 and 5 when we could have just done it in a 2-step process, or sometimes 3 to get to 8 and 5. Go ahead and circle your answer. And moving forward to number 10. Oh my goodness, decimal to the 10th, no big deal. Let's go ahead and start by labeling our A, our B, and our C values. Wonderful job. All right, now, can we factor this out? No, we cannot, because there are not two factors that when multiplied give us -21 and when combined give us that +8. So we do have to take the long way home. X equals, and we're just following that quadratic formula. Bring in the negative, enter that B value, identified as 8. Bring down your plus minus, open up that radical. And again, we'll put that B value, which is 8 in parentheses. We'll square it. We'll do -4 times our A value of 1 times our C value of -21. And we will set that over 2 times our A value in 1. All right, the good news is that when we are working with decimals, again, we can simply do what's in green as an entirety, and we don't have to break it down into an extra portion. All right, so let's go ahead and take a look. We have negative times our 8 here. And again, if we put this into our calculator, it's simply just going to spit out a -8. So let's do X equals. We'll bring down our -8. And again, continue to bring that plus minus. And because it's looking for a decimal, we can do the entirety of this. All right. So let's go ahead and just highlight that. And when you see that radical highlighted as well, yes, that does mean to go ahead and enter that into our calculator as so. Second, x squared, open, 8, close, x squared, -4, open, 1, close, open, negative 21, close, hit enter. What do we get? 12.1655. Oh my goodness, we have a decimal, but good news is it wants it to the decimal. Now we have our 12, we have our point, and this 1 is in the 10th column, okay? Now the 6 here in the hundredths will determine if we keep this 1 the same or if we round up. Now, if it's 0 through 4, so this 6 in the hundredths, if it were a 0 through 4, well, that 1 would stay the same, but 5 through 9, it gets rounded up to a 2. And considering that in the hundredth column we have a 6, this becomes 12.2. All right, so we will put that as 12.2. And we will set that over our 2 times 1 in brown. Please don't frown. I know it's a little long, but it's okay. You've got this, and yes, we've got this. All right, so we will set it up again as 2 separate equations here. X equals, we have our negative 8. We will do plus 12.2 over 2. And then again, we will do x equals negative 8 minus 12.2 over 2, and set that equal 2. No, not a 2, I know. And again, we'll highlight just to show the computation, okay? Negative 8 plus 12.2. What does that give us? Yes, it does, a 4.2. All right, we'll set that over our brown 2. And if we do 4.2 divided by 2, I know I probably don't need to highlight this, but I like to. That equals, wonderful job, 2.1. Circle your answer. And again, we will do it one more time on the bottom. Negative 8 minus 12.2. What does that give us? Yes, a negative 20.2. And again, we will divide that by 2. And I will highlight this in pink just to show you exactly everything as we do our negative 20.2 divided by 2. And what does that give us? X equals negative 10.1. Go ahead and circle your answer. All right, and moving forward to number 11. Now, numbers 11, 13, and 17, I believe, should have a radical within the response. And let's go ahead and take a look at this just to see the way it breaks down. All right, so it will look a little different as we go through this because they cannot be factored. They will look a little different, and it also does not want it to the 10th. But let's just go ahead and plug and chug our quadratic formula. All right, we have x equals, bring that negative, open up, put in our b of 15, bring down your plus minus, open up that radical. We have that b squared, so we'll put in our 15, close it, square it, minus 4 times a, which is 1, times c, which is negative 9. We will set that over 2 times a, so we'll set that over 2 times 1, and I'll walk you through the computation just a little different this time. All right, we will put x equals, and what I highlighted in red will give us that negative 15. All right, continue to bring down your plus minus. We will actually put the radical here, and I just want to show you why. All right, so let me go ahead. I'm not going to highlight that radical, am I? No. So in your calculator, I just want you to do 15 squared, and because that's positive, you don't need to put the parentheses. If it were negative, you would definitely need the parentheses. All right, so that's going to give us 225. Now in orange here, if I did negative 4 times 1, I'd get negative 4. Negative 4 times negative 9 would give me a positive 36. So I'm just going to put it as plus 36. In brown, we will do our 2 times 1. So let me set that over 2 times 1, which is, yes, it's 2. Thank you. Great job always. All right, from here, we'll just continue to simplify. All right, so x equals, bring down your red, negative 15. A lot of things stay the same here. Can you tell? I know you can. All right, bring down that plus minus. And again, I'll put the radical. And then this time, we will do 225 plus 36, which gives us 261. All right, we will do set that over our 2. All right, so for this next portion here, what we need to do is we need to, and I'll put this in pink. All right, we need to find those factors of the square root of 261. All right, so let's go ahead and write it as x equals, put down our negative 15. All right, plus minus. Now, in our factors of 261, if we have a perfect square, we need to simplify that radical even further, just like we did in numbers 2 and 3. All right, so let me go ahead, and I'm just going to write something on the side here. All right, I'm just going to put that the square root of 261 is equal to, all right, the square root of 9 times 29. And the square root of 9 times 29 is equal to, yes, we do have a perfect square within that 9. So 3 square root 29. All right, it's supposed to be a 9. Sorry about that. So when we simplify this even further, we're just simply going to write it as x plus minus 3, the square root of 29, which cannot be broken down any further, and we will set that over our brown 2. Go ahead and circle your answer. Now keep in mind that everything, all right, right here, we do a negative 15 divided by 2 because it is set over the 2, and the plus minus 3 square root of 29 is definitely over 2 as well. So just note that in mind, that it's everything divided by 2. All right, moving forward to number 12, find the solution. Set x squared plus 25 equals 0. All right, let's get x squared by itself. Yes, minus 25, minus 25. In a lot of this test, I wish it was organized better. That way we can kind of walk through each and every single one of them in a perfect flow, but unfortunately our test creators did not do that for us. All right, yes, it'll be randomized on an SAT, but while we're in class learning these things and building that comfortability, I think we should probably just sequence everything kind of skill by skill. But hey, that's just me. Who am I? All right, I'm just Noomber. All right, x squared, we will take the square root of both. X squared, square root is x equals. Now remember, yes, 25 is a perfect square. However, it's negative, so it's just going to be x equals plus minus the 5. And because it's negative, we'll put the I. Go ahead and circle your answer. You might see that as 5i and minus 5i, just like before as well when we were looking for the solution set. So yes, Noomber, you did make an error on that one. All right, moving forward to number 13. We will rock this the same as 11. Let's go ahead and start by labeling our A, our B, and our C values. All right, let's get that negative going. Our B is negative 7. All right, bring down your plus minus, open up that radical. Negative 7, we'll square it. That looks like poop. Minus 4, I'll extend this out, times our A, which is 1, times our C, which is 9. We will set this over 2 times 1. All right, and let's go ahead and rock that computation. All right. So we have a negative times a negative 7. So our x equals, and we'll start off by putting the 7 there. We'll bring down our plus minus. And again, we will just do this as 2 separate here. So again, I will start with the blue, and I will not highlight the radical. And in your calculator, if you do it as so, just like that, you will get 49. All right, now, one more time. As so, negative 4 times 1 is negative 4 times 9 is negative 36. So we can do minus 36. Let me go ahead and, meant for that to be brown. Put this over our 2 times 1, which is 2 times, 2 times 1, which is equal to 2. Oh my goodness, sometimes I do make some errors along the way. We will bring down our 7. We will set that equal to, and what I highlight here in green is 49 minus 36, which equals 13. So x equals 7 plus minus the square root of 13 over 2, and it cannot be simplified any further as 13 is a prime number. Go ahead and circle your answer. So a little easier than 11. So if I'm writing this test, I might put this one is 11, the next one is 13, but again, who am I? All right, number 14, square root of 243 equals, well, 243 is not that perfect square, and again, this looks like above before. We have 3 times 81. Oh my goodness, 81 is a perfect square, so we can write this as square root of 243 is equal to the square root of 3 times 81. We've identified our greatest perfect square within 243, so it equals the square root of 81 is simply 9, and what's under the radical stays under the radical, which is 3. Go ahead and circle your answer. For number 15, the square root of negative 25 is equal to, yes, plus minus 5i. Circle your answer. And for 16, 3x squared minus 37 equals 11. All right, we'll start by getting that 3x squared by itself. So plus 37 and plus 37. Bring down your 3x squared. Cancel those bad boys out. Equals 11 plus 37 is 48. The next step will be to divide each by the coefficient of x squared, which is 3, giving us x squared equals 16. Then we will have to take the square root of x squared to get x by itself, and what we do to one side we do to the other. X equals plus minus 4. Moving forward to 17, it wants it to the 10th. All right, again, we can kind of do a little oddball computation here. Let's do our A, let's do our B, and let's do our C, and let's just follow that formula of x equals. Let's put that negative. Let's put our B of 11 in parentheses, bring down the plus minus. Open the radical. We will do our 11 squared for that B minus 4 times A, which is 1, times C, which is 4. We will set that over 2 times A, which is 1, and we will begin to do our computation. All right, so if we put that into our calculator as so, we would get x equals negative 11. Bring down that plus minus. Now again, I will highlight this entirety in green with the radical because it wants it to the 10th. If we're using decimals, we're not going to be simplifying. We're going to just simply be finding an answer with a decimal, meaning we can take the entirety of this. All right, so let's go ahead and do that for 17. Let's take a look. And if we hit second x squared, we open our parentheses, we put in the 11, we close it, we hit x squared, minus 4 times our A value of 1 times our C value of 4. We hit enter, we get 10.24. Should we make it a 10.3 or do we keep it 10.2? Well, 0 through 4 in our hundreds column is a 4. That stays the same at 10.2. All right, so that equals 10.2. And then we will set that over 2 times 1, which is wonderful job. It's a 2. All right, so let's just continue to push and plug along. We will break this up into 2 separate equations. X equals negative 11 plus 10.2 divided by 2. We'll put that in brown, and then we will write one more equation with it as x equals, and I'm just going to go ahead and put that in there, negative 11 minus 10.2 divided by 2. And if we go ahead with our computation, we have negative 11 plus 10.2, giving us negative 0.8 or negative 0.8. We can take that, we can divide it by 2. Let me get our brown out. All right, and then that will equal, if we put that into our calculator, we should get negative 0.4, because we're cutting that negative 0.8 in half. That will be one of your x values, and then for the next one, we will do negative 11 minus 10.2, which equals negative 21.2. we will set that over 2. And again, we will do our computation of negative 21.2 divided by 2. All right, and then that should equal negative 10.6. And let me just confirm just to be 100%. All right, it is negative 10.6. Thank you very little. Go ahead and circle that as your answers. All right, for number 18, oh my goodness, what do we do? Well, let's start by getting that quantity with the 2 in front of it by itself by adding 31, not just to one side, but to, great job, both sides. All right, so bring down the quantity with the 2 in front of it of x plus 6 squared. Cancel those bad boys out. 67 plus 31 is 98. Great job. All right, now, if we would distribute that 2, that would tell us to multiply. What can we do? We can divide by 2. And what we do to one side, we do to the other. And when we do that, we're just going to simply, boom, kind of get rid of that. And then we're going to bring down our x plus 6 squared equals 98 divided by 2 is 49. Great job. From here, we can to pull the quantity of that x plus 6 out, to get it by itself, since it's currently squared, we can take the square root. And what we do to one side, we, yes, do to the other. So that allows us to pull our x plus 6 out equals 7 comma negative 7. All right, and then for our last step here, we will do minus 6. And what we do to one side, we, yes, do to the other, giving us, ooh, I don't like that's in pink. It probably should have been in blue, but that's okay. 7 minus 6 is 1, comma, negative 13. Go ahead and circle thy answer. Moving forward to the next one, where are we? 19 and 20. All right, I'm only going to go through this factored form. I'm not doing quadratic formula. All right, x squared plus 13, x plus 36. I'm going to write it as x plus 4 and x plus 9, making my solutions x equals, yes, we take the flip sign of what's inside, minus 4. All right, and then we have x equals, yes, the flip side of what's inside, negative 9. Go ahead and circle your answer. For number 20, I'm going to do the exact same thing, okay? Because 8 times 1 is 8, and we can find factors of negative 4 times negative 2, giving us a positive 8. So I'm going to write it as x minus 4 and x minus 2, because that negative 4 times negative 2 gives us the 8. Negative 4 minus 2 gives us our negative 6. All right. There will be one added step to this, and that's it. But again, let's take that flip. So x equals 4 and x equals 2. Now, I'm going to highlight something here in red, okay? That's our a value. You see that 8? What we need to do with it, it's still in play. It's not 1, so we're just going to simply divide each by 8, giving us x equals a half and x equals 1/4. And you can take that shortcut if you're good with factors. If not, go through the quadratic formula, and that is your review.